Hello student, now our next point in electrostatic chapter is scalar form of Coulomb's law. So Scalar's law. So first find out what is the Coulomb's law. Coulomb's law means Coulomb's law is a fundamental law governing attraction between charges at rest. Okay, so now we see a scalar form of Coulomb's law. So now statement is the force of attraction or repulsion between two charges or point charges at rest is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So means F means force of attraction or force of repulsion, because two point charges are same, means like charges or unlike charges. So here force of attraction or repulsion, any force, okay, is directly proportional to the product of the magnitude of charge. So product of magnitude of charge means here considering two charges Q1 and Q2. So here product of two charges means Q1 into Q2. And inversely proportional means force is inversely proportional to the square of the distance between them, means R square. So we get here F is directly proportional to the Q1 Q2 upon R square, inversely proportional to the square of distance between them. So F is equal to K, where K is proportionality constant, Q1 Q2 upon R square. So here what is the K? So now find out what is the K. So this is the scalar form of Coulomb's law. Now we find out a K. So what is the proportionality constant? So let us see our next point. This is the relative permittivity or dielectric constant. So while discussing of Coulomb's law, it was assumed that the charges are held stationary in vacuum. When the charges are kept in a material medium such as water, mica or paraffin paper, the medium affected the force between the charges. The force between the two charges placed in a medium may be written as, so F medium is equal to 1 upon 4 pi epsilon Q1 Q2 upon R square. So here what we see here see that Coulomb's law held in stationary in vacuum. So in vacuum means here no medium, okay, no air. And then suppose we kept in material medium such as water, mica and paraffin paper, this medium. So this in vacuum the charges are Q1 Q2 and here distance is R square. But in place in medium, the force between the two charges placed in a medium may be written as, so in this place in medium, so we get here F medium, okay, 1 upon 4 pi epsilon Q1 Q2 upon R square. Suppose means here K is, we get here 1 upon 4 pi epsilon. So here epsilon is called the absolute permittivity of the medium. This is the formula for force in medium. This is, we know that this is the Coulomb's scalar form of Coulomb's law, and this is the, suppose Coulomb's law placed in a medium means it's water, air, any, okay. And next one, similarly the force between the same two charges replace in our space or vacuum, means a free space or in vacuum, the distance is R, then we get a formula. So here we get a formula F vacuum. F vacuum is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. So we get here two forces. So first one is F vacuum and F medium. So this Coulomb's law in for free space or vacuum, and this formula for F medium, for medium, water, mica, N. Okay, so dividing equation number 1. This V vacuum suppose as one equation and F medium is supposed as two equation. So dividing equation 2 by 1 we get means F vacuum divided by F medium is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square upon 1 upon 4 pi epsilon Q1 Q2 upon R square. Okay. So here 1 upon 4 pi epsilon naught 1 upon 4 pi epsilon naught. So here correction one is here medium na. So here epsilon only, write the formula epsilon only because we know epsilon, and here epsilon naught for free phase. For vacuum we know write here epsilon naught. Okay. So 1 upon 4 pi epsilon naught Q1 Q2 upon R square 1 upon 4 pi epsilon Q1 Q2 upon R square, and this term is cancel out and its only remaining term is epsilon upon epsilon naught, because 1 upon 4 pi Q1 Q2 because here two charges place in vacuum and also similar charges place in medium. So this term is cancel out and remaining terms only epsilon upon epsilon naught. And here the ratio of epsilon upon epsilon naught is the relative permittivity or dielectric constant. This ratio is called a relative permittivity or dielectric constant of the medium and is denoted by K. So we get here what is the K in scalar Coulomb's law. So this proposed the constant K we get epsilon upon epsilon naught, or also write is the epsilon R. Okay, this written K or epsilon naught any. So we get this value means dielectric constant is equal to epsilon upon epsilon naught. So epsilon for F vacuum and epsilon naught for F medium. Okay, so we get this formula is nothing but F vacuum upon F medium is equal to epsilon naught. Okay, here write on is equal to okay F vacuum upon F medium. Okay, so thus epsilon R or K means dielectric constant is the ratio of absolute permittivity of a medium to the permittivity of free space, or epsilon R is the ratio of the force between 2 point charges placed a certain distance apart in free phase or vacuum to the force between the same 2 point charges when placed at the same distance in the given medium. So here this quantity means epsilon R is dimensionless quantity because epsilon and epsilon is same dimension. So here cancel out. We get here dimensionless quantity. So epsilon R is also called a specific inductive capacity. It's also called a specific inductive capacity. And the force between 2 point charges Q1 and Q2 placed at a distance R in a medium of relative permittivity epsilon R then is given by, suppose here we get F is equal to 1 upon 4 pi epsilon naught epsilon R Q1 Q2 upon R square. So for water epsilon R is equal to 80. Then frequency of this, then from equation F vacuum upon F water is equal to epsilon R is equal to 80. So F water is equal to F vacuum upon 80. So this means that when 2 point charges are placed some distance apart the water, to the force between them is reduced to 1 by 80 of the force between the same 2 charges placed at the same distance in vacuum. Okay. सपोज आपण इथे जर चार्जेस 2 चार्जेस पाण्यामध्ये ठेवले आणि ते 2 चार्जेस जर व्हॅक्यूममध्ये ठेवले त्यातलं डिस्टन्स काय असेल तर रिलेशन काय असेल F water is equal to F vacuum upon 80. Okay, so got it this point also. So all this discussion we find out the material medium reduces the force between charges by a factor of epsilon naught. its relative permittivity. Okay, so another definition for unit charge. So unit charge means 1 coulomb is the amount of charge which, when placed at a distance of 1 meter from another charge of the same magnitude in vacuum, experiences a force of 9.0 into 10 raised to 9 Newton. Okay, so put up these all quantities. Suppose here Q1, Q2 is 1 coulomb and R is the 1 meter distance. Then we get this value, and this value is 9.0 into 10 raised to 9 Newton. Okay.